In this video, we have to understand a new concept about Kubernetes service. By default, whenever we are creating the Kubernetes service, its default values about the external traffic policy and session affinity are configured. But we can change its values based on our some specific requirement. If we have some application that needs session consistency, so in that case, we can change these values. And session consistency applications like games related applications, whenever e-commerce application checkout is happening, so session consistency is imperative. Similarly, video conferencing and chatting related applications need session consistency. If session switch to another pod, in that case, it will make the problem for the application. And the whatever the transaction is happening, its processing will be disturbed. So, external traffic policy controls how traffic from outside the cluster is routed to the pod. Its default value is cluster, and if the default value is doing the default behavior of load balancing across all nodes, whatever so far we learn about service, that if there are multiple pods associated with the service, so whenever you will hit the service IP, it will route the traffic in the round robin fashion to all the pods. And if we change its value to local, then it will route only to the pods on the same node as the traffic ingress, preserving the client source IP. Mean if you hit the worker node 1, and if worker node 1 is running that specific pod that you need to be reachable by that specific service, then it will respond. If that pod is not on that worker node, then it will not respond. Mean it will not route your traffic to the other worker node, that is the default behavior of the service, to fetch wherever the pod is. If you have 10 worker nodes and your only 2 pods are running, so you can hit any worker node to reach that specific service that is running inside the pod. So it's the responsibility of the service, the kube-proxy, to make sure you can reach to that specific pod. So this default behavior will not work if you set its value to local. And session affinity is determining if Kubernetes should keep user sessions sticky to the pod. And this is based on the source IP. The default value is none, mean no need to make any affinity the users with specific pod. But if we change its value to client IP, then it will make sure the client keep routing to the same pod, and it will be decided based on the source IP. So these two parameter when we will enable, then this will make sure the source IP is actually reaching to the pod, and it will make sure whenever that source specific IP is coming, that traffic should always be landed to that specific pod. So in the real-time system, the session consistency related applications are like e-commerce whenever checkout is happening. So if user is doing refresh, then in that case, the user session should always be landed to the same pod, because that pod is doing the checkout process. If the pod will change, then the checkout process will be disturbed. Similarly, games related uh, access, video conferencing, chatting related applications need session consistency. So let's start. I have a Kubernetes cluster. So first of all, I will show you the default behavior, and then we will implement these uh, changes in the Kubernetes in the service, and we will observe how it's working. So I created a deployment. So it's a very simple deployment. Let me apply this deployment. Okay, deployment is ready. Now I will just expose this, create a service in front of this deployment, and we will observe the default behavior. Expose this deployment, port 80. So service is created, and its cluster IP is there. And if I do kubectl get svc -OYML, so you can see the session affinity is by default set to none. Okay, now kubectl get pod and get svc. It's a cluster IP type of service. I need to edit this service, and I will make this service like node port. So this port we can use from outside the cluster. I'm using my system browser and I'm accessing this port on my worker node 3, and I can reach this service. So if I kubectl get pod -avoid, so you sorry, it's for my worker node 2, not 3. So it's running on worker node 2. And now if I hit to worker node 1, it's also responding me. So request goes to worker node 1, and worker node 1 forward the traffic to the worker node 2 because pod is only running in worker node 2. So now if I do kubectl logs -f, I want to see what source IP is exactly coming. So whenever I am refreshing, so you can see this is the source IP, and this is from within the kube-proxy, some IP that is responsible to take this traffic. The actual IP is not reaching inside the pod. So now let's create the service in front of this deployment with the sticky session based changes. So let me first delete service, and I created this service file, and this service file does contain is a node port type, and its external traffic policy is set to local and session affinity client IP. Let me just apply this, and its name is app1 service. kubectl apply -f kubectl get svc. So service is created, node port type, and now this is the port that I will hit on worker node 1, but I know my pod is running on worker node 2. So let's see what happens. This is the node port. When I did try to hit this worker node 1, it's not responding because worker node 1 does not contain the port. So now if I do the same port web-based access on worker node 2, I can get the access. So how this happen? This is because of these external traffic policy defined to local. So we can see if I open the logs now, so you can see the difference here. Previously, its source IP was from something from within the cluster, but now it's changed to actual IP of from where I am hitting accessing this. So now actual IP is coming to the application. So we test two things, mean worker node 2 is not responding and worker node 1 is uh, worker node 1 is not responding but 2 is responding. Now let me just kubectl get deployment, and I will scale the deployment uh, to two replicas, and definitely I believe the second pod will go to worker node 1. So two pods are created. Okay, so my cluster is not overloaded. That's why it's equally dividing the load to both the nodes. So now each node does contain one pod. So now when I will refresh for this page that was not responding, it's also showing me the page. But its traffic is going to worker node 1 only, and its traffic is only going to worker node 2. Okay, but normal behavior, is quite different. So with this way, we achieve that traffic should be local, and the source IP we also make sure is the actual IP of the system, of the user that is trying to access the application. So let me now quickly show you my network. I am using this whole lab on my VMware workstation, and this is the network adapter. My virtual machines are connected with the NAT network, and here my IP is 159.56. Okay, so all the traffic that is going from this source IP is going to this these ports. So let me just change this IP to show you. If I change this IP to 57, I lost the SSH connection because I changed the IP. I will make the new connection. Okay, now I am connected, and kubectl get ports, and let me just refresh this page. These both pages, one is going to worker node 1, one is going to worker node 2, and kubectl logs -f to any of the pod. So the source IP is also change. Okay, so we understand how source IP is actually coming directly to the pod. Now we have to understand the session stickiness with the pod. So far we are running one pod in each worker node. So how we can validate that a session is sticky with the specific worker node, specific pod based on the source IP. Now if I uh, for this reason, what I will do, I created this index.html file, and it will show us some background color with something written on the page. So let me do kubectl get deployment. Let me scale this deployment to 4 pods. So now 4 pods are running and 2 are on worker node 2 and 1 on worker node 2 are on worker node 1. Both nodes has 2 pods. So now I have this index.html and I set the background to red and application, I'm just writing application for session based testing, and here I will write red variant 1 and I will do the copy in the of this file in one of the pod in the web root. Okay, it's copied. So now I will modify this index.html to green. This pod will show us the green page. So in the other pod, the second pod, I will upload this page. Now index.html I will change to blue. In third pod will entertain the blue page, and last one I will set to yellow. This is our last pod. So now just for the testing purpose, I will locally curl red, green, blue, and this pod has yellow. Now when I will refresh this page is changed to green background and some message we printed here. And now I refresh and this is on worker node 1 is traffic is landed to red pod. So the application is same. I just created the different web pages on all the pods just to show you the stickiness of user session based on IP. So worker node 1, worker node 2 both have two pods. Each is entertaining the different color of background. So now we have to just understand that right now our IP is 57. So what I will do, just making a note here, IP57 is showing us the red and green, red and green color. Let me now change the IP to 58, and now I will refresh. There are quite chances the traffic may go to the same pod, but let's see if maybe it will change the request to the new. So now it's landed to the blue, and this page is sticky with the red. So it's mean the IP58 is now sticky with blue and red. Okay, now I will change another IP. So I just want to show you when I will revert back the IP, we will see the same pages. I'm changing the IP to 59. IP is 59, and let me just refresh. It's again set to red, and it's set to green, red and green. And one more I will do, maybe this one. Should I refresh multiple time? Okay, it's sticky. And now I will change the IP to 60. I just want to make a different IP. I set 70. Refreshing. 70 is associated with red and this. Let me check. I believe all the pods are running. Two are running on worker node 1 and two are on worker node 2. No problem. But we just created a combination. If IP is 70, its color is set to blue and red. It's unfortunate that traffic is not going to yellow. It's random. We cannot force, but it's totally dependent. Maybe by changing the browser, we could test. Now it's sticky. Let me again change the IP network. Strange, it's not going to yellow, but we just created a combination. So now whenever I will switch to IP57, it will always show me red and green. green, shifted to green. So it decision is made based on the source IP. So 57 is always red and green. Pods are only red and green pods are associated with 57 IP. Now let me just change to 58 quickly. So 58 is red and blue. It will remain red and it will switch to blue. And one more test, 70 red and blue and red and green, 59 is red and green. It will remain red and it will switch to green. So with this way we test that all the pods are sticky with the source based IP decision. So this was just a practical example how we can implement this in our professional life to make the traffic sticky with the specific user. So now definitely in production environment whenever we will create this service, so this service will be not like node port, it will be load balancer, and in cloud it will automatically create the load balancer. So this service here we will use the load balancer. So the load balancer we can configure with the IP hash based policy, mean source IP should always be route to a specific worker node only, and then the pods will automatically decide this IP is coming for this pod. So now we can, if we are running this Kubernetes cluster on premises, so in on premises we can have a physical firewall where we can make the IP hash based decision. I mean, by sometime the load balancer is doing the round robin fashion. It's not taking care the IP should always go to the same worker node. So this we have to take care when we will create the load balancer. And second thing, we must have to take care, we will not add the worker nodes with the load balancer, those who does not contain the running pods. Otherwise, the traffic will go to the worker node and it will not entertain because the pod will not be there. So the another solution is right now what we did, we just tested with the randomly and we landed pods in both the worker nodes. But if you have multiple worker nodes, so in that case you can deploy such type of session affinity applications in the form of daemon set. Daemon set will create a pod on each worker node. Or we can make the affinity node based affinity pods. Only these pods will remain on these specific worker nodes, and those worker nodes will only be added with the load balancer. So such type of techniques we can use to make sure your application availability.